Determine all intervals of increasing trend or decreasing trend and determine the coordinates of all maxima, minima, plateaus, or cliffs of the function f of x equals x plus 4 over x. The first thing to do is find the domain. F of x equals x, which is a polynomial term and has a domain of all reals, plus 4 over x, which has a denominator, and the domain requires that the denominator cannot equal 0. The denominator here is an x, therefore x cannot equal 0. So the domain is all real numbers except for 0. So it starts at negative infinity, up to 0, not including it, so round bracket, union, begins again at 0, not including it, round bracket, up to positive infinity. That domain is all real numbers except for 0. 0 will be a vertical asymptote here. The next thing to do is find all critical numbers. We'll take the derivative, but before we do that, let's rewrite the function because the second term is a quotient, but a quotient rule isn't needed because the numerator is a constant. So we can bring the denominator up by writing it to a negative power, x to the negative first power, and just use the power rule. So f prime of x equals, first term is constant times x, derivative is the constant. Second term is a power rule. Bring down the power, multiply it with the 4, and subtract 1 from it. Since we have a negative power, we will want to rewrite that second term by moving the x down so it can be to the positive power. Since our first derivative has at least one term that has a denominator, we have to combine all terms over that common denominator in order to find critical numbers. So we need to multiply the 1 by x squared over x squared, a form of 1, to give it the common denominator, minus 4 over x squared. 1 times x squared is x squared. Combining it with the other numerator, minus 4, over the common denominator of x squared. We now want to fully factor the first derivative. The numerator is a difference of squares, and we'll factor into an x plus 2 and an x minus 2. The denominator is a single term, and it'll stay as is. We can now set the numerator equal to 0 and the denominator equal to 0 and solve for all x's. Starting with the numerator, x plus 2 times x minus 2 equals 0. This gives x equals negative 2, where x equals positive 2. Now the denominator, x squared equals 0. We can take the square root of both sides. The square root of x squared is x, and the square root of 0 is 0. We now check to see which of these are in the domain. The domain is all real numbers except for 0. X equals negative 2 is real, and it's not 0. X equals 2 is real, it's not a 0. But the x equals 0 is not in the domain, and we have to cross it out. So we have two critical numbers, x equals negative 2 and x equals positive 2. We can now draw a domain line. The domain is negative infinity, which is no left end, to positive infinity, which is no right end. But right at x of 0, there's a vertical asymptote. So we can indicate that by drawing the vertical asymptote right there at 0. So the domain is already split into two intervals. We can now put the critical numbers on the domain line. Negative 2 will be to the left of 0, and positive 2 will be to the right of 0. And these further split the domain up into now 4 intervals. We can pick a test value in each of these intervals. In the interval negative infinity to negative 2, we can pick negative 10. From negative 2 to 0, we can pick a negative 1. From a 0 to 2, we can pick a 1. And 2 to positive infinity, we can pick a positive 10. We can now test the trend of each of these intervals by plugging these test values into the first derivative. We don't care about the value of the first derivative, just whether it is positive or negative. So the best place to plug in would be the fully factored version. Plugging a negative 10 in will give a negative 10 plus 2, which is negative, times a negative 10 minus 2, which is also negative. Negative times negative is positive, over a negative squared, which is positive. The denominator here will always be positive for the first derivative because it's squared. So we result in a positive first derivative for this interval, which corresponds to an increasing trend. Now we can plug a negative 1 in to the factored version. The denominator is going to be positive again. Negative 1 plus 2 is positive. Negative 1 minus 2 is negative. And a positive times a negative is a negative. We have a negative first derivative, which corresponds to a decreasing trend. Now we can plug positive 1 in. 1 plus 2 is positive. 1 minus 2 is negative. Positive times negative is negative. So we have a negative first derivative, which corresponds to a decreasing trend. And we can plug a positive 10 in. 10 plus 2 is positive. 10 minus 2 is also positive. Positive times positive is positive. Again, the denominator, being that it's squared, is always positive. So we have a positive first derivative and an increasing trend. So we have the function is increasing on the interval negative infinity up to negative 2. And then again from positive 2 to positive infinity. And we have a decreasing trend from negative 2 to 0. And then again from 0 to 2. Those two intervals cannot be combined because 0 is not included, and that's why it has round brackets on it. At the critical number of x equals negative 2, the trend changed from having been increasing to being decreasing. Increase to decrease would indicate that there is a relative maximum at the x-coordinate of negative 2. We can find a corresponding y-coordinate by plugging the negative 2 into the original function. So y-coordinate equals f of negative 2, which will be negative 2 plus 4 divided by negative 2, which is negative 2, and then 4 divided by negative 2 is negative 2. Negative 2 minus 2 is a negative 4. X equals 0 is not a critical number. It's a vertical asymptote. And then the critical number of x equals 2 has a trend decreasing and then increasing, which indicates there will be a relative min at the x-coordinate of positive 2, which will have a corresponding y-coordinate, which can be found by plugging the x-coordinate of 2 into the original function, which will give 2 plus 4 over 2. 4 over 2 is a 2, and 2 plus 2 is a 4. So we have a relative max at negative 2, negative 4, and a relative min at 2, 4.